cord. All right, number 4. Do we have a GCF in number 4 of 27, 36, and 96? Hey. Do we have a GCF on number 4? Yeah, what? What do you guys think? Huh? 9? Can 9 go into 96? No. I would think 3, don't you guys? If 9 can't, I would try 3, and 3 can. So 27 divided by 3 is 9, p squared. 36 divided by 3 is 12p. And 36 divided by 96 is 32. Okay. Do we have a GCF in 5? Nope. What about 6? No. 7? Do we have a GCF between all of those terms? Yeah. What can go into 200, 120, 40, and 24? 4. So let's factor out a 4 out of these. What's 200 divided by 4? 50. Yep. 120 divided by 4? 30. 40 divided by 4? 10. And 24 divided by 4 is 6. And then in number 8, do we have a GCF? No. Okay. All right. Once we get our GCF, then our next thing is we looked at, we're going to factor either a binomial, a trinomial, or a polynomial. And they're all a little bit different, aren't they? Yeah. A binomial, we look for, and you guys can't see that, sorry. For a binomial, we look for a difference of 2 squares. Okay, difference of 2 squares. So the only binomials are 5 and 6 here. Do we have a difference of 2 squares? Yes. Okay, we have a difference, which means subtraction, and these are perfect squares because they're even exponents, right? All right, so to factor out difference of 2 squares, remember we make 1 plus, 1 minus. What's the square root of a squared? A, because isn't a times a squared? And what's the square root of 9b squared? 3b. And there you go. And then double check in the minus one again. Is this a minus 3b a difference of 2 squares? Nope. So this would be your final answer here. Okay. Number 6, do we have a difference of 2 squares? Huh? I think we do, right? Difference minus, and they're both perfect squares, correct? So let's do 1 plus, 1 minus. Square root of 9x squared, 3x. So that goes in the front. And the square root of 4y squared, 2y. And then always check again. Is 3x minus 2y a difference of 2 squares? No. So you're done. Good. All right. All right, trinomials. Okay. For trinomials, remember, we do our a times c that adds to be b. And then we learn 2 ways after you find those factors. Either you can do by grouping, or you can do that divide by a method. Okay, doesn't matter which one you do. No. Okay, and for some reason, I want to say that most of you guys did the grouping method. Did anyone do the dividing by a? Did you guys all do grouping method? Grouping? Okay. So looking at a here, okay, so our grouping method, okay, x squared goes in the front, right? Plus 72 goes at the end. Okay. Now a is 1 here. We really don't need to do grouping, but that's okay. We'll keep going this way. Now my a times c is 72. And what's my b here? Negative 17, right? So what times what is 72 that adds to be negative 17? Negative 8 and negative 9. So we have minus 8x and minus 9x. And then what do we do after you set it up here? You factor out your GCF, right? So what's my GCF between x squared and 8x? X. So we have x minus 8. Since 9x is negative, we pull out a negative. And what's my GCF between 9x and 72? 9, and I'm left with x minus 8. So for this one, bless you, you have x minus 8 times x minus 9. Now, when a is 1, remember, you don't necessarily have to do the grouping. Your factors automatically make your binomials, okay, when a is 1. But does it matter which method you use? Bless you. No. All right, let's look at number 2. Okay, so a is 1 again. So we don't actually have to do the grouping method here because it's a little bit longer. So I'm going to keep my GCF out in the front here. B is going to go in front. And now let's do our a times c. 1 times negative 90, bless you, is negative 90. And my b is negative 1. So what times what is negative 90 that adds to be negative 1? Sorry. 10 and 9. Which one's negative? Negative 10 and positive 9. Why is it negative 10? Because it needs to add to be a negative 1. So minus 10 plus 9, and it doesn't matter the order you do that in. And there you go. Just make sure you keep that GCF in the front. Okay. All right. Looking at number 3 here. Okay. Now a is not 1, so we actually have to do the grouping method. Okay. So we're going to keep that 5 out in front as my final answer, but I'll worry about that in a second. So we're going to do 7r squared and the plus 6 here. Okay, so my a times c, 7 times 6 is 42. And what's my b? 13. Okay, so what times what is 42 that adds b 13? What times what is 42 that adds b 13? 7 and 6. So 7 and 6, so I'm going to put plus 7r and plus 6r. Doesn't matter where you put them, right? Okay, now let's factor out our GCF. 7r squared and 7r, what's my GCF there? 7r. So I'm going to pull out a 7r there. And aren't I left with r plus 1? What's my GCF between 6r and 6? 6. And I'm left with r plus 1. The r plus 1s need to be the same, okay? So, which they are. So we're going to put r plus 1 as 1, and then the GCFs go together as 7r plus 6. Leaving that 5 in the front because that's your GCF, okay? Yes, Tori. Yeah, that's fine. Yeah. You have a problem seeing that? Sorry. Anyone else having problems seeing? Okay. All right. Number 4. Okay. So number 4 in this sentence, okay, we have the 9p squared minus 12p minus 3p, keep that 3 out in the front. I'm going to put 9p squared negative 32. All right, so my 8 times c here, 9 times negative 32. Tori, can you mute your?
Oh.
Thank you. It was echoing. I'm like, oh. All right, so what's 9 times negative 32? Negative 288. And we add b, which is negative 12. So what times what is negative 288 that adds b negative 12? Anyone do that? Yeah. You guys are laughing. Anyone? Anyone? 12 and 24? Which one's negative? Yep, good. That's all right. Sometimes they do. So do you want to put the 12 or the 24 first? Does it matter? No. So let's do the 12. We have 12p and then negative 24p. All right, so factor out our GCF. So I'm going to go down here if that's okay, you guys. All right, so looking at 9p squared and 12p, what's my GCF between that one? 3p. And what would I be left with? 3p plus 4. Okay. Now, since 24 is negative, I'm going to factor out a negative number. And what's the GCF between 24 and 32? That'd be 8. And if I take a negative 8 from negative 24, wouldn't that be a positive 3p? And if I take a negative 8 from a negative 32, isn't that a positive 4? Yes. So these are the same, which is great. So we keep our GCF, that 3 in the front. We keep our 3p plus 4 the same. And then we have our GCFs of 3p minus 8. And there you go. All right. Now, a polynomial. So when we looked at 4 terms, okay, this is where we did that factor by grouping. And remember, I already said we're only going to do where you have to group the first 2 and the last 2. Okay, so we're going to kind of do what we did in this sense with the trinomial. It's already set up in that. We just have to actually add in the grouping for it. So I'm going to do 8 first here. So since there was no GCF originally, so I'm going to group the first 2 and I'm going to group the last 2. And we're going to do exactly what we just did with the trinomials. What's my GCF between 8x cubed and 5x squared? X squared. And if I take an x squared, I'm left with 8x plus 5. Okay. In the second group, my 32 is negative, so I factor out a negative number. And what is my GCF between 32 and 20? 4. So I'm going to take a negative 4 from a negative 32, which gives me a positive 8x. And I take a negative 4 from a negative 20, that makes a positive 4. Okay. So now we have this x squared minus 4 times 8x plus 5. Oh, yeah. So, yeah, I typed this wrong. It's because I typed it wrong. Yeah, that was supposed to be, yeah. Oh, I wrote it wrong. Not typed it wrong. I wrote it wrong. Huh? Yeah, I wrote it wrong. I didn't type it wrong. I wrote it wrong. Sorry about that. All right, now, anything else that we noticed from this? Are we done? Peter? We do have a difference of 2 squares here. We do. X squared is a perfect square. 4 is a perfect square, and we have a negative. So we need to make 1 plus and 1 minus, and leaving the 8x plus 5. So square root of x squared is x, and the square root of 4 is 2. And there you go. And again, the order you guys have these in does not matter because multiplication is commutative, right? Okay. All right, and then this last one here. Okay, so our final answer is we're going to have 4 in the front here, okay? But we're going to do the same thing we did before. So let's group that first 2 and group the last 2. What's my GCF between 50n cubed and 30n squared? 10n squared. And what would I be left with? Minus. Good. We have a negative 10n in the second group, so I'm going to pull out a negative number. And what's my GCF between 10n and 6? Did you guys say 2? So negative 10 divided by negative 2 is 5n. 6 divided by negative 2 is a negative 3. So they are the same, right? And I wrote it correctly this time. So I'm going to put the 4 in the very beginning there because that was our GCF from our original. We have this 5n minus 3, and then we have the 10n squared minus 2. Do we have a difference of 2 squares here? I'm going to say no. Why? Is 10 a perfect square? No, it's not. Is 2 a perfect square? No. It is a minus, but it's not a difference. Okay. All right. Any questions with that factoring? Do you guys remember all of that now? Yeah. Good. Good. Okay. Now what we're going to do is, you remember how we solved equations back in chapter 1, chapter 2, chapter 3? We're going to solve equations, but remember, before, all of my x squareds always canceled out. Now my x squareds aren't going to cancel out, okay? So now our equations, a quadratic equation, is when we have this like ax squared plus bx plus c equals 0, okay? A, b, and c are numbers like we've done, but now we're going to solve for x squared, okay? And when we solve for x squareds here, okay, just so you guys know, that degree tells you how many possible answers you potentially could have as a max. So if my highest degree is 2, that means we could possibly have 2 answers for x. Okay. Now, one way to solve these is by factoring. Okay. So the difference between our linear equations, like 2x plus 3 equals 10, you know how to solve this, right? You would subtract the 3, divide by the 2, right? This is a linear equation. Quadratics, we have a possible of 2 answers. Okay, yeah. I know. I think it's just the HDMI cord and all that fun stuff. Okay. And I think it would be connected to the printer or the projector. Okay, so the first thing, when we have an x squared, I want you to set your equation equal to 0. Okay, every single time. Okay, every single time, set your equation equal to 0. Then, do we know how to factor a trinomial? Yeah, so we're going to factor completely. So what we just did, GCF. And then if it's a binomial, is it a difference of 2 squares? Is it a, if it's a trinomial, your A times C, all of that fun stuff. Then we're going to use this 0 product property to solve. Okay. And what is the 0 product property? Okay, so I'm going to go here. Okay. The 0 product property is, it says for every real number A and B, A times B will equal 0 if and only if A equals 0 or B equals 0, right? Because if A equals 0, 0 times anything, isn't that going to be 0? Or if B equals 0, anything times 0, isn't that going to be 0? Yeah. So what this means is you're going to set each group equal to 0 and solve it. Okay. So what does that actually mean in that sense? Okay. So if I look at example 1, if you notice these, isn't every single one of these already factored? Yeah, they're already factored because they're in those parentheses. So they're already factored. We're going to use that 0 product property. So what that means is we're going to set each group equal to 0. So I'm going to say x plus 2 equals 0 or x minus 5 equals 0. Okay. So how do I solve x plus 2 equals 0? Wouldn't I subtract the 2? So x would equal -2. Or how would I solve the next one? Add 5, so x would equal +5. Now, why does this work? Okay, because if I plug -2 into x, would that equal 0? Let's see. What's -2 plus 2? 0. What's 0 times -2 minus 5, which is -7. Is 0 times -7 0? Yeah. If I plug in 5, 5 plus 2 is 7, but 5 minus 5 is 0. So isn't 7 times 0 still 0? Yeah. So these are your two answers. So anytime you see an x squared, we have two possible answers for that. So we're going to factor it and set each part equal to 0. Okay, what this actually means, guys, this means my graph, if I would actually go and graph this, my graph would cross the x-axis at -2 and 5. That's what that means. Okay. All right, go ahead and do C for me. The nice thing, again, these ones are already factored out for us. So we don't have too much, we don't have to factor yet. Okay. So go ahead and do. All right. So I would take 2x minus 3 equals 0 or x plus 5 equals 0. So what are my two answers? X would equal 3/2. Yep, 3 over 2. Or x would equal -5. Awesome. Okay. Now, let's look at B and D. What's different about B and D here? They have a GCF, right? A number in front. So here's my question. How many n's are actually here? 3. So how many possible answers am I going to have? I'm going to have 3, okay? Because think about this. If I multiply, what's n times n? N squared. And what's n squared times 5n? 5n cubed. So my highest exponent is actually 3. So that gives me 3 possible choices, okay? Just so you guys have an idea. Not always are you going to have 3, but that's the max number you possibly could, okay? But now, since there's 3 n's, we're going to have 3 parts we have to set equal to 0. Our first part would just be 5n equals 0. My second part would be n minus 3 equals 0. And my third part would be n minus 4 equals 0. Okay. So what would my first n solution be? 5 times what equals 0? 0. So n would equal 0. N minus 3 equals 0. What's my second solution? 3. And the last one would be 4. So what this means is this graph, if we graph it, would cross at 0, 3, and 4. That's it. Okay. All right, go ahead and do D. And I don't know why I put N, X, and make them all N's or all X's. They should be the same variable. This one I typed wrong. How's that? Huh? I know. Or 2n plus 5 equals 0. 3n minus 4 equals 0. So each part equals 0. So what's my first one? N would equal 0. N would equal -5/2. because you subtract the 5, divide by 2, and my last one, 4/3. So you add the 4, divide by 3. So my graph would cross the x-axis at 0, -5 halves, and 4/3. Okay? All right. Example 2 is now just factoring it. Okay? So now we're going to get into the factoring sense of it. Okay? Now, what did I say first, though? My equations always have to equal what? 0. So how would I move this 12 over to the x's? Subtract it. Yeah. So I'm going to have 2x squared plus 5x minus 12 equals 0. Make sure you're in standard form. Do you guys remember what standard form was? Highest exponent down to the lowest. Okay. So now let's go ahead and factor this. Do we have a greatest common factor? No. So I'm going to do my grouping. 2x squared, -12. Okay. And now let's do our a times c that adds to be b. So what's 2 times -12? -24. Adds to be b, which is 5. So what times what is -24? That adds to be 5. What do you think? 8 and 3, which one's going to be positive, or which one's going to be negative? 3, yep. So we're going to have positive 8x, negative 3x. And again, it doesn't matter where you put the 8 and 3, okay? What's my GCF between 2x squared and 8x? 2x. And aren't I left with x plus 4? Okay. My 3x is negative, so I have to pull out a negative number. And my GCF between 3 and 12 is 3. So -3 divided by -3 is a positive x. -12 divided by -3 is a positive 4. Okay. So we have in factored form, we have 2x minus 3 times x plus 4. And then we have to set it equal to 0. Now we factored it. Have we solved it now? Nope. So we set each group equal to 0. And we solve. So what are my two solutions? What would my two solutions be? 3 halves, yep, and -4. Why? Because you add the 3 over, divide by 2, subtract the 4 over. Good. All right, go ahead and do B for me. Go ahead and do B. All right. So how do you guys move that 9y over? I would subtract the 9y. Where would that 9y go? Would it go at the end or in between? In between. So minus 9y plus 1 equals 0. Okay. All right. So do we have a GCF here? Nope. So we're going to factor by grouping. Plus 1. All right. So let's do my A times C. So 8 times 1 is 8. And what's my B? Negative 9. So what times what is 8 that adds to be negative 9? Negative 8 and negative 1. So let's go negative 8y, negative 1y. What's my GCF between 8y squared and 8y? 8y. And I'm left with y minus what? 1. Since it's negative, I need to pull out a negative number. And what's my GCF between 1y and 1? 1. And I'm left with y minus 1. So we have 8y minus 1 times y minus 1 equals 0. Are we done? No, because now we've factored it, but we haven't actually solved it because there's an equal sign. So we're going to set each group equal to 0 and solve. So y minus 1 equals 0. So y equals 1 because you add the 1. 8y minus 1 equals 0. Add the 1 over, divide by 8. So we have 1/8. Any questions with that? Does that make sense to you guys? Yeah, okay, good. Let's look at C and D here, okay? Looking at C, what's my highest exponent? 3. So we have a possible of how many answers? 3. In D, what's my highest exponent? 4. So we have a possible of 4 answers. Exactly, okay? Now, sometimes they can repeat, but not all the time, okay? But that's the possible. Do we have a GCF in C? Yes, what's my GCF in C? 2y. Anything else bigger than that? Nope, just 2y. Okay. Now, are we in standard form here? No, so I'm going to go ahead and write this in standard form when I divide out 2y, if that's okay with you. 18y cubed divided by 2y would be 9y squared, right? What would go next, the 8y or the 24y squared? 24y squared. So what's 24y squared divided by 2y? 12y, right? And then 8y divided by 2y would be 4. You guys okay with that? So now this is my GCF, okay? That's going to stay on the outside when I factor it, but also it's going to say 2y equals 0, doesn't it? For one of my choices. Now let's keep going. All right, let's factor our trinomial by grouping. So we're going to do 9y squared plus 4. All right. So it's 9 times 4. 36. And my b is 12, right? So what times what is 36 that adds to be 12? 6 and 6, doesn't it? So we have 6y and 6y. What's my GCF between 9y squared and 6y? You guys get 3y? Yep. So 3y divided by 9y squared would be 3y plus 2. You guys okay with that? What's my 6y is positive, so we're going to pull out a positive number. What's my GCF between 6y and 4? 2. And what am I left with? 3y plus 2. So we have 3y plus 2 times 3y plus 2. What do you guys notice about these? They're the exact same, aren't they? So how many actual answers are we going to get from this? Just one, because they're going to be the same, aren't they? So if I put 3, Yep. So there are only going to be 2 answers in this sense. Yes, exactly. So 2y equals 0, divide by 2, so y is 0. And here would be -2 over 3. Right. So in this case, we could have had a maximum of 3, but we actually only had 2. This is called a multiple, okay? A multiple answer. Okay. All right. Now, looking at this one, okay, you notice we have y4. We have 2 of them. Do you guys want to keep going and do this one, or do you want to go to the story problems, your guys' favorites? Do this one? Okay, first. All right. So we're going to factor by grouping. So we have y to the 4th, and we have +9 here. All right, so let's do my a times c that adds to be b. A times c is 9, and what's my b? -10. So what times what is 9 that adds to be -10? How about -9 and -1, right? So does it matter where we put them? No. So I'm going to go ahead and put the -1y. Now we have to do y squared because my middle term is y squared, isn't it? And then we have a -9y squared. Okay. And I switched them around just because I thought putting the 9s together would be easier. Okay. All right. What's my GCF between y to the 4th and y squared? Y squared. And what am I left with? Y squared minus 1. My GCF between -9y squared and 9, -9, and I'm left with y squared minus 1. So now we have y squared minus 9 and y squared minus 1. What do you notice about these? They're difference of 2 squares, aren't they? So we can do 1 plus, 1 minus for each of these, can't we? All right, square root of y squared is y, actually for all of these, aren't they? What's the square root of 9? 3. So we have +3 minus 3. And what's the square root of 1? 1 and -1. And then this equals 0. So this is my factored form. And now we need to set all 4 parts equal to 0. So y plus 3 equals 0, y minus 3 equals 0, y plus 1 equals 0, and y minus 1 equals 0. Whew. So what are my answers? -3 and +3. So is it okay if I put plus or minus 3? Have you guys ever seen that plus or minus before? This plus or minus thing means I can have a +3 and a -3, just so I don't have to write it out twice. Okay. And y could equal what? -1 and +1. So plus or minus 1. So there are your 4 answers. All right. Whew. Any questions with this one? Do you see why we reviewed factoring before we did it? Yeah. Okay. So like I said, this is pretty much the last part of the section of chapter 5 is just solving it. So now you guys have learned how to solve equations with x's. You've learned how to solve equations with x squareds and x cubes and x to the 4ths, right? So the main thing is set them equal to 0, factor. Okay, anything greater than a single x. So if you see x squared, x cubed, x to the 4th, factor. Factor, factor, factor. Okay. All right, let's look at story problems now, your guys' absolute favorite. Now, the good news is I don't have any of these ones on the finals, okay? But I do have ones of where you have to subtract the areas, you know, that kind of stuff. All right, so let's look at this one. A decorator plans to place a rug in a 9x12 room so that a uniform strip of flooring around the rug will remain uncovered. Go ahead and draw me a picture. Go ahead and draw me a picture here. here. Do you guys draw a rectangular room? And what size is my rectangular room? 9 by 12. Good. And then we have a rug, don't we? Being placed, and here's my rug, so that we have a uniform strip around the outside, right? Do we know how wide this flooring is around the rug? No. So can I go ahead and say we went X up to the top, X to the down to the bottom, X and X? Are you guys okay with that if I use X in that sense? That the space between the rug and the room, the wall, is X units. So if I know this length is 12, if I bring it in X units to the right and X units to the left, how long is my rug? -12 minus 2x, yes. Why? Because we're bringing X in both directions, right? So we know the length of my rug is 12 minus 2x. What is the width of my rug? 9 minus 2x. Good. You guys okay with that? All right. How wide is the strip of area of the rug? Okay. So how wide? So we're looking at the width of my rug. Okay. If the area of the rug, so the area of my rug is half the area of the room. Is means equal, doesn't it? And half means 1/2 times the area of the room, right? You guys okay with that? Now, do we know how to find the area of a rug? Yeah, how do we find the area of a rectangular rug? Length times width, right? So length times width. So my length is 12 minus 2W. My width is 9 minus 2W, or I guess X. I don't know. I changed it from X to W for some reason. Sorry. Equals 1/2. What's the area of my room? Length times width again, right? What's my length of my room? 12. And what's my width of my room? You guys know what to do here? Could you guys solve this? Yeah, we can multiply, couldn't we? How do I multiply two binomials? Not factoring, because this is actually factored form. This, we need to FOIL it, unfactor it, which is FOIL, right? Or distributive property. So let's go ahead and do that. What's 12 times 9? 108. 12 times negative 2W? Negative 24W. Negative 2 times 9, negative 18W. Negative 2W times a negative 2W is a positive 4W squared. Equals. What's a half of 12? 6. 6 times 9? 4. Okay. All right, now looking at this sense, okay, we know we have a W squared. So how many answers could we possibly have? 2. So we need to set my equation equal to what? Zeros. How do I move 54 over? Subtract them. What would I subtract 54 from? 108. Good. What's 108 divided by 54? Or minus 54, sorry, not divided. 54 equals 0. What's a negative 24W minus 18W? A negative 22? 42, sorry, 42. Sorry about that. My bad. Like, oh, that's not right. All right, and then we have 4W squared. You can have X, I put W's. I don't know why I changed it. Okay. Now, do we know how to solve this? Yeah. What do we have to do? We factor it, don't we? Yeah. Do we have a GCF? Yeah. What's my GCF? Nothing 2, 2. All right. So if I take a 2 from 4w squared, I'm left with 2w squared minus 42 divided by 2 is 21 plus 54 divided by 2 is 27. Now, if you guys notice this, my GCF before always had a variable. Does this one have a variable? No. So would I set 2 equal to 0? No, there's no variable. So this 2 just is there for factoring form. It's not there for actually solving. Now, let's go ahead and factor this. So 2w squared plus 27. All right. So A times C, what's 2 times 27? 54. And adds to be B, which is negative 21, right? All right, so what times what is 54 that adds to be negative 21? Huh? 3 and 9. No. 3 and what? No, you're fine. I just wasn't, I don't know. Okay, 3 and 18, both negative, right? I'm hearing sound from here because Aubrey's actually unmuted, but I kept hearing sound and then I couldn't listen. I don't know. So then we have minus 3w and we have a negative 18w, right? All right, what's my GCF between 2w squared and 3w? Just w, right? And I'm left with 2w minus 3. Negative 18, so I'm going to pull out a negative. And what about 18w in 27? Say 9. And I'm left with what? 2w minus 3. So we know my factor form is 2 in front, w minus 9, and 2w minus 3. Now, we factored it. What haven't we done yet? We haven't solved it. So go ahead and solve it for me. Now let's go ahead and solve it. So w could equal 9 or y negative 3 halves, positive 3 halves. Okay. Now, one thing on these types of problems, we always need to check it. Why do you think I need to check it? Because what does this w or x represent? With their length, right? It's our x, how much we bring into something, right? So we need to be able to plug these values in and not get a negative length or a negative width in something, right? Yes. Okay. So let's start with 9. Let's plug 9 in here. Okay. What is 2 times 9? 18. What's 9 minus 18? Negative 9. Can I have a width of my rug be a negative 9? No. So could 9 be our solution? No. This is rejected, right? Okay, we reject it. That cannot, because we end up getting a negative length in that. Let's try 3 halves. What's 2 times 3 halves? Isn't that 3? And 9 minus 3 is 6. So we know my width is 6. Let's try my length. What's 2 times 3 halves again? 3. And what's 12 minus 3? 12 minus 3? 9. So does 3 halves work? Yeah, so we know my length and my width of my rug is, my width is 6 and my length is 9 meters. Okay. Does that kind of make sense to you guys? You have to, with story problems, you have to check up, okay, especially when it comes to these types of problems. Now, the nice thing, huh? You do. You do have to solve it. Okay. Any questions with that so far? Okay. Now we only have 15 minutes left. There are some more story prompts. I'm going to go ahead and just work through them, but I'll go ahead and let you guys work on your assignment now so that if you guys have questions, you can start asking. And then I will post these guys ones up with you so that you have them. Again, on the homework for this, it is on Canvas. I need to put it up on the board, but I assign the odd problems for you. And again, why do I assign odd? I want you to check your work. However, that means you have to show your work, okay? So no straight answers for this, okay? Now, for this assignment, it is due on Thursday so that if you guys have questions with it, I will not take late work on this assignment, okay? So make sure you guys have it done for Thursday, okay? So this assignment needs to be posted by Thursday because we start finals next week anyways. We're not testing on this section, okay? It will be on your final, but that's it, okay? Does that make sense to you guys all? Okay. All right. And again, I will work out these. Those that are online, you're more than welcome to hang out, keep working on the assignments. And like I said, I will get this posted and the recording